We will learn about Lean Architecture Toolkit and various work products or artifacts which this toolkit provides us. Also, we will look into a few architecture design patterns relevant for SAP BTP with use cases. And finally, we will see the development approach to introduce SAP BTP. For those who are not familiar with us, Mindset is the technology partner of choice for leading global organizations that want to leverage exceptional user experience on the SAP platform. I'm Juhi Kulshreshtha, a Senior Manager Development, and I'm heading technology team of Mindset based out of Bengaluru, India. And I'm having more than 18 years of experience in implementation, operation, and support of SAP solutions. So before I start with ADM approach, Amy, could you please help me to launch poll number 1?
Yes, I will. All right. And we'll give everybody just a minute to answer the poll question. Looks like we've got a lot of responses, so I'm going to end that poll and share the results. All right.
Yeah, thanks, Amy. So as per the responses, around 26% of attendees have not yet started their BTP journey. 62% have started exploring services in BTP, and 12% are in the middle of BTP transformation. This gives a very good idea about the mix of attendees present in this webinar. And thanks, Amy, for sharing this. All right, moving ahead with the ADM approach. The question is, why do we need ADM approach? To build an enterprise software, you need to build foundation and follow a certain methodology. A few examples of these methodologies are Zachman, SAFe5, and the Open Group Architecture Framework, or TOGAF. In order to show how modern development in SAP BTP can be driven out of an established development framework, we will follow TOGAF here. The approach proposed by TOGAF to plan, implement, and govern enterprise is called Architecture Development Method, or ADM. As per TOGAF, ADM consists of 9 phases within 4 levels of architecture domains: business, data, applications, and technology, as shown in the figure here. Only the first 5 phases are relevant for BTP. As you can see here, phase A comprises of architecture context. In this phase, you start defining the high-level aspirational vision for the architecture, the high-level scope of a project, and set the context for expectations and constraints for architecture development. Key work products are statement of architecture work, architecture vision, business goals and drivers, and capability assessments. In phase B, which is business architecture, you define the business capability in the context of the project that are to be addressed by the architectural work. This is where you dig down to business goals and capabilities. And in phase C, which is information system architecture, we combine data and application domains in an effort to describe and document your organization's IT landscape. In addition, you document data and information being processed. In this phase, you take the statement of architecture work and try to bring in the high-level target application and data architecture to fit that vision. And phase D is the technology architecture phase. The conceptual data and application components that are defined in the previous phase are picked up and mapped to the corresponding technology components, such as runtime environment, hardware platforms, software products or services, and so on. Here you work on the architecture to make the whole solution more concrete. Typical work products for this phase include technology components and their relationships, environment and locations, hardware specifications, and sizing. For the purpose of how to develop an architecture for SAP BTP projects, we need not focus on project management, change management, or implementation methodology at this moment. So coming to the solutioning approach, there are various external factors as shown here, which give rise to requirements. And there are two main drivers of architectural work in an organization. First one are business drivers like market demand, economic demand, customer demand, regulatory demand, and so on. And the second one is technology drivers like cloud computing, machine learning, Internet of Things, and so on. And all of these external factors give rise to this jumbled ball of requirements over here. Architectural thinking helps to address the problems in an engineering mindset with a focus on technology and business. And the ADM tries to address the problems from a technical feasibility standpoint. However, in practice, to drive innovation, a user-centric view needs to be factored as well. So you need to take an approach that combines design thinking with architectural thinking to infuse human element and user centricity into the design and architecture of the solution. This allows you to apply a creative mindset to understand the problem and solve it in an innovative way. In real life, this concept can be illustrated by a simple example of an application which can be used for analyzing purchase orders by a procurement manager. From architectural point of view, such an application can be created by using solutions such as SAP Data Warehouse and SAP Analytics Cloud. But this shows only half the picture, as finally the procurement manager should be able to use it efficiently. The application should be designed in a manner that it should be easy to navigate, easy to read, and derive insights from. And this is where design thinking comes into picture. Now let's look at the phases and outcome. So in a project lifecycle, design thinking and architectural thinking can go hand in hand across different phases of explore, discover, design, deliver, run, and scale. This figure shows how design thinking steps and artifacts complement the corresponding ADM steps and work products in these different phases. For example, in explore phase, the design thinking methodology talks about innovation ideas and how the stakeholders are aligned with that innovation process. For architectural thinking, you can complement the thoughts here with the strategy map. Similarly, in the discovery phase, in design thinking, you do research and inventory, which can be complemented with the baseline application architecture. And in design phase, you can make things more concrete and produce target application architecture in architecture development side, which can help build a design thinking prototype. During the delivery phase, you work on the final product and set out the future direction, which can be powered by the roadmap work product. Finally, in the run and scale phase, you get feedback and optimization, and which this overlaps with implementation of and governance and operational excellence in the architectural side. And at the top of this page, you can see mindset specific phases where the scope phase coincides with explore phase in design thinking and architectural thinking. And after that, the next phase is discover phase, where we try to find out as many problems as possible, do research, and then try to converge into one single problem. And in frame phase, we again do brainstorming and try to find out as many solutions as possible. And after a number of iterations, we validate and find out one single solution. And in the deliver phase, we deliver this particular solution in iterative cycles and provide a better product in each of these iterations. So this is how the phases of design thinking and architectural thinking complement each other. So before we move ahead with Lean Architecture Toolkit, I would like to conduct one more poll here. Amy, could you please help me to launch the poll again?
Yeah, absolutely. Okay, everybody should be able to see that poll. And again, we'll give everybody a couple minutes to answer. And it looks like it's slowing down a little bit, so I'm going to go ahead and share the results to keep us going. All right.
All right. Thanks, Amy, for this. Yeah. As per the responses, around 25% of people think that lean architecture toolkit would be beneficial, and 39% answer is maybe, and 36% are unsure about it. All right, let's dig deeper into this toolkit to understand its importance in establishing minimum viable architecture. Lean architecture methodology infuses proven lean and acceleration concepts with established architecture practices. In this part of session, you will see how to adapt lean enterprise architecture to put modern development into formal practice. As discussed earlier, the architecture work can be triggered from two main drivers: business drivers and technology drivers. The Lean Enterprise Architecture Toolkit provides guidelines on these work products in business and technology domains to drive the architectural work in the right direction. The Lean Enterprise Architecture Toolkit comprises 15 work products, and 7 of the work products describe the business domain, which are being shown by dark blue dots over here, and 8 work products describe the technical domain, which are being shown by yellow dots over here. Work products from the business domain are used to communicate with stakeholders from the business departments, as well as business executives and business management. And work products from the technical domain are predominantly used to communicate with stakeholders from IT. Each work product of the toolkit can be described by a template, which can be adopted to create the work product. Generally, the work products of the toolkit are applied in a defined sequence. The reason for this is that results from one work product serve as input for the creation of other work products. And there can be different starting options for using the Lean Architecture Toolkit. Depending on the driver for architectural work, the sequence of using templates of the toolkit can be adapted. Considering a business department that issues a request of architectural work, the strategy map over here or statement of architecture work might be one of the first work products being created. In case the IT department would like to discover the business value of using a specific technology, the solution concept or baseline solution architecture might be the work products to start with the architecture development. Using the Lean Enterprise Architecture Toolkit involves different activities for the creation of work products. Each work product offers a different view on the architecture. It is the sum of all the work products describing the architecture of the aspired solution. You can also take a fast lane to produce essential minimum viable architecture. This fast lane is shown by this particular thick line. Let's see the work products on fast lane in both business and technology domain. So the first work product in this fast lane is strategy map, which is in business domain. This helps to align with your corporate strategy. This helps to understand the business impact of your architectural work by mapping project goals to the company's strategic goals. It is a graphical representation of the organization's goals and objectives. It visualizes the strategic intentions of the organization and decomposes them into related drivers, goals, and objectives. For example, strategic goal can be something like fast and effective approval of business initiatives and research and development projects. And objective can be something like reduce average time of approval from 25 plus days to 2 days. Next work product on the fast lane is statement of architecture work, which is again in business domain. This work product defines the scope and approach that will be used to complete the architecture development of your project. The statement of architecture work is typically the document against which your successful execution of architecture project will be measured. You can consider statement of architecture work as a document of understanding. It helps you regain focus on the scope and avoid scope creep. As it is formally agreed upon, the statement of architecture work helps you to officially say no to request or requirement coming up throughout the architecture development that are out of scope. Next work product on this fast lane is a solution context diagram. This is again in business domain. This work product shows the relationship between the proposed architecture, between the proposed solution and the organizational units, business roles, business functions within the enterprise. The goal of the solution context diagram is to provide a high-level overview of the aspired solution that can be easily understood by the business. Therefore, the solution context describes the required business capabilities that need to be satisfied by the architecture. Prerequisites for creating solution context are the stakeholder matrix and statement of architecture work. Specifically for stakeholders from business domain, the solution context is a good visual representation of the architecture, showing how your anticipated solution interacts with different organizational units, roles, and business functions. And the next work product is solution concept diagram, which is the first work product in the technical domain. This is a high-level representation of the aspired solution via architecture building blocks. The solution concept diagram is a transition step between the solution context and the solution realization diagram. It is a macro version of your architecture, mainly comprised of vendor-neutral architecture building blocks. The purpose of solution concept is to provide a high-level representation of your solution, and this is envisioned in order to meet the requirements of your architecture engagement. You can consider the solution concept as a pencil sketch of your expected solution based in architecture building blocks. The next artifact is solution realization diagram, which is in technical domain. It is a technical description of the aspired solution via solution building blocks. The solution realization diagram describes your target architecture by breaking the aspired solution into functional components based on solution building blocks. The purpose of solution realization diagram is to add technical details so it can be used for implementation phase of the aspired solution. Solution building blocks are product or vendor aware and can be either developed or procured. With solution building blocks, you outline which products like cloud services are used or need to be developed in order to realize and implement the aspired solution or its architecture building blocks. And the next artifact on the fast lane is software distribution diagram. This document shows how your solution is structured and how the solution building blocks or architecture building blocks are distributed across the IT infrastructure. And this gives a clear picture of how the documents are hosted. And the last work product on this lane is architecture roadmap. And this roadmap outlines actions that are required to realize the architecture. The architecture roadmap is an overview of specific actions that are required to realize the aspired solution. It lays out the individual actions on a timeline to show the sequence and progression from the baseline architecture to the target architecture. The purpose of the architecture roadmap is to discuss the optimal implementation sequence. And once the architecture roadmap is complete, we can start, implementation of our minimum viable product. Let's discuss another way of looking at architecture building block. Let's start by drilling down into the data layer. So these architecture building blocks are specific to SAP business technology platforms. And right now they are technology agnostic, which means that the real names of the components have not been used over here. Only the capabilities have been described in this diagram. So let's start by drilling down into the data layer. The data layer supports the BTP data to value scenario and serves as the basis for other layers or other building blocks sitting on the top. The data layer or architecture building block brings the ability to connect to and store any data, no matter the source, format, location, or volume. And based on the connected data, the data layer offers orchestration capabilities among the data, supporting different features such as physical data replication, federation, or pipelining. And based on this, higher level data services such as preparing, cleaning, transforming, and enriching the data are offered. Important to mention are the analytic feature of the data layer, as well as the semantic knowledge, especially about the SAP data stores. The individual building blocks making up the data layers are consumed as managed services and implement cloud qualities like elasticity, scalability, and high availability. Next layer, which is consuming the data layer, is the application layer. The application layer is also composed of different building blocks, and we can name one subcategory of building blocks in the application layer as digital process. And building blocks of this digital process subcategory support the realization and improvement of digital business process. Starting from left to right, there is a building block that allows you to integrate different processes based on events, messaging, and APIs, for example. Also, building blocks supporting process automation via rules, workflow management, and bots, for example. And a third building block offers analytic functionality such as simulation, planning, and the creation of dashboards and reports, for example. And another building block provides you with domain-specific services for lines of business or industry-specific scenarios. And another architecture building block offering functionality to deploy custom application or your custom business process following different programming paradigms. Now, within the application layer, we can add a second subcategory of building blocks named digital experience architecture building blocks, which again comprise of two architecture building blocks, one for central user entry to connect people or users with the required business processes, and second architecture building blocks to realize a digital workplace based on collaboration, which is personalized and role-based sites, and which offer access to business application and content. Now, in addition to the data layer and the application layer, the SAP BTP also has a layer for delivery component, which is a cross layer that are used within the data layer and the application layer. This cross layer delivers architecture building blocks for supporting developer productivity, such as tools and programming models for or frameworks. And another architecture building block deals with security offering services like authentication, as well as authorization and trust management. Based on these BTP building blocks, you realize the previously mentioned scenarios, data to value integration and extension. Looking holistically at the building blocks, you can also think of grouping them into model view controller paradigm, whereby the data layer is a model, process building blocks within the application layer, the controller, and the digital experience building blocks within the application layer, the view. This architecture building block oriented view actually helps us to transition over solution concept diagram to solution realization diagram. Let's see a few architecture design patterns. We will be discussing monolithic architecture, microservice-based architecture, serverless architecture, and event-driven architecture over here. Talking about monolithic architecture, traditionally in a monolithic architecture as shown here, different parts of the applications are shared in a single code base and different developers are developing in a single gigantic system. Our traditional ABAP environment is a classic example of this kind of architecture. Some of the advantages of monolithic architecture are that these are simple to use, It is easy to search the different functionality, and deployment is relatively simple. And some of the disadvantages are that monolithic architectures do not have features like scalability and high availability. For example, if the process of lead to cache is designed as a monolithic application, then it will be difficult to scale the application only for the part lead, quote, and order, as the end user activity is maximum for this part of the application. The usage or activity reduces during delivery and invoicing. Sometimes we need to scale for a given part of the application and not the entire application, and different parts of the application demand different scalability. This horizontal scaling is often not possible, and vertical scaling is expensive. You may argue that you can also modularize development even in a monolithic architecture, like the one shown in your right side, but this leads to architecture which is tightly coupled. The second disadvantage of monolithic architecture is that the availability is a problem, because even for change of one single line of code, the whole application needs to be deployed again. Now, in contrast, microservice-based architecture decomposes the application into smaller sizable services. These services are fairly independent and loosely coupled. This slide shows concept of microservice architecture, where entire lead to cache functionality is now decomposed into multiple microservices. Benefits of microservices-based architecture are that these are easier to develop independently. These can be built or managed by different distributed teams. These can be developed using different technology stacks. Each service can be deployed individually and independently. Scaling is easier and can achieve zero downtime for an application. And some of the challenges of microservice-based architecture are possible increase in operational complexity, skill set management, support of CI/CD and DevOps, and network latency. So one of the use cases for microservice-based architecture is intelligent ticketing system for service industry. Customers can reach out to the company for complaints, feedback, and requests through multiple channels like Facebook, LinkedIn, or company's portal. These messages coming from different channels can be posted to a microservice created using CAPM in SAP BTP, which then can leverage the destination service to submit to appropriate microservice catering to these different kinds of messages. And the runtimes which support microservice architecture in SAP BTP are Cloud Foundry, ABAP, and Kyma. Now, talking about the serverless architecture, the main concept in serverless architecture is to rely on platform provided service. In such cases, you need not pay for the whole service subscription, but just pay for the used computing time amount. Usually this is billed per compute time or compute unit. This is also known as function as a service, shown over here. This slide shows the difference between the concepts of infrastructure as a service, platform as a service, software as a service, and where function as a service fits in. In infrastructure as a service, or IaaS, organizations rely on service provider for hardware only. Whereas in PaaS, the OS and hardware both are provided by the PaaS provider. PaaS acts almost FaaS acts almost like SaaS in the sense that the entire stack is owned by the FaaS provider, which you can see that there is a very slight difference between FaaS and SaaS, but it allows tenants to use functions and customize them on per compute basis. So here you can see a slight difference in color, which shows that functions and applications can be customized as per the requirement. The advantages of the serverless architecture are that it reduces long-term maintenance, increases speed of innovation, focus on core functionality, and performs risk and compliance mitigation, and allows cost to be tied to usage. And some of the disadvantages are that it has less control and flexibility, and it limits compliance if the platform doesn't support, and provides for potential vendor locking. Coming to event-driven architecture, this architecture, also known as reactive architecture, goes hand in hand with the serverless as well as microservices architecture. One of the key principles of cloud native microservices and serverless architecture is to ensure service to service communication. It's essential to collaborate and communicate between services, components, and containerized services to successfully orchestrate the purpose of the bigger application. In a basic setup, this can be done via HTTP-based communications. However, this type of communication really starts getting entangled in a point-to-point network. For a scalable and robust application, this is a limitation. Event-driven architecture advocates that one service communicates with another service using an event bus or event broker. Once certain conditions are met and a service needs to communicate with another service, a designated event is triggered to the channel. The event broker maintains the event queues or topics, and the subscribed events get immediate notification of this event by consuming the event from the event queue. This has a clear benefit as all the services are now loosely coupled and only hooked up to the event bus. In this way, the whole architecture is scalable. And some of the benefits of this kind of architecture are real-time communication, greater operational efficiency, better scalability and fault tolerance, increased versatility, and synchronous communication. And some of the challenges are dealing with complex data and system architecture, designing and chaining events, tracking event flows, making synchronous flows. Generally, event-driven architectures follow fire and forget. So it's not good fit for synchronous calls. Talking about the SAP Event Mesh, which is another service provided in SAP BTP. SAP Event Mesh is a fully managed cloud service included in SAP BTP that allows applications to communicate through asynchronous events and seamlessly extend your digital core. You can build event-driven extension applications, publish business event, provide seamless connectivity, and decouple communication using SAP Event Mesh. Solving the issue of scalability, SAP Event Mesh enables the reliable exchange of messages between sender and receiver applications, which could be one or many. Asynchronous communication takes place between the application, services, or systems, wherein the sender application isn't bogged down by waiting for a response from the receiver, and a receiver can subscribe to critical business needs and can consume the messages on their own pace. It would be interesting to know more about decoupling here. Moving away from point-to-point integration is really great to remove the dependencies between the systems. But what does decoupling or loose coupling mean? The different dependencies which this kind of architecture can resolve are runtime dependencies, which can be solved with asynchronous messaging, where the sender system can submit a message to the middleware, and this is independent from the availability of receiver. Another dependency is data format dependencies, like converting different formats, for example, from XML to JSON and vice versa. The decoupling takes place via converters. Similarly, another dependency is of data structures, which can be different, for example, different formats of zip code or country code. So before we go ahead with the features of Kyma, I would like to conduct another poll. And Amy, could you please help me to launch the poll again?
Yeah, absolutely. All right. You should see it, I hope. Oops. Let's see here. Are you seeing that poll at all? Not understanding, but it does not seem to be launching. Juhi, are you seeing the poll?
No, no, Amy, I can't see it.
Oh dear. Let's see here.
Still, I can't see it, Amy. If you're not, I mean, it's not possible to launch the poll, then we'll just move forward with.
Yeah, we seem to be having a little bit of a technical issue with this particular poll. I'm not sure exactly why, but I will try it again. The questions on the poll, so people could think about it, was, do you have a preference on Cloud Foundry over the Kyma Runtime environment? And if those of you that have an answer on that, the answer choices were yes, no, or undecided. If you have any thoughts on Cloud Foundry versus Kyma, I'm probably saying it wrong. Feel free to add it into the chat box. And apologies for that. I'm not sure what's malfunctioning, but it does seem to be malfunctioning. All right, back to you, Juhi. Sorry about that.
Thanks, Amy. No worries. So let's get to know more about Kyma environment and find out its features and uses. So SAP BTP provides a fully managed Kubernetes runtime based on the open source project called Kyma. This is a fully managed cloud native solution that provides a runtime for containerized applications. Kubernetes provides the basis of architecture to support massive containerization. Kubernetes is an open source platform for deploying and managing containers. It provides a container runtime, container orchestration, container-centric infrastructure orchestration, self-healing mechanism, service discovery, and load balancing. Kubernetes helps orchestrate the underlying computing, network, and storage infrastructure, and it enables application operators to focus entirely on container-centric workflows for self-service operation. On a high level, Kubernetes consists of a control plane, distributed storage etcd, and a number of cluster nodes or kubelets as shown on the screen. Control plane is the system that maintains the records of all Kubernetes objects by managing object states and responding to changes in the cluster. Control plane is made up of three major components: Kube API server, Kube controller manager, and Kube scheduler. This can run on a master node or can be replicated to multiple nodes. The API server provides APIs to support lifecycle orchestration, and client authentication is done via the API server as well, and proxy or tunnel to the node can also be done through this. The cloud controller manager integrates into each public cloud for optimal support of availability zones, virtual machine instances, storage services, and network services for DNS routing and load balancing. Cluster nodes are the machines that run the containers and are managed by the master nodes. The kubelet is the primary and most important controller in Kubernetes. A kubelet is the main node agent that runs a cluster node. It's responsible for driving the container execution layer, typically Docker, and pods are the key constructs that the developers interact with. A pod represents a running process on a cluster. Now coming to the Kyma runtime again, and this shows a high-level view of the Kyma runtime. Kyma runtime is a fully managed Kubernetes runtime based on the Kyma open source project. The functionality offers smooth composition of SAP and non-SAP applications in a highly scalable environment with the support of event-based and API-based extensions. The Kyma environment consists of a Kubernetes cluster provisioned through the Gartner project on the cloud provider. Every Kyma environment runs on a single Kubernetes cluster on a specific sub-account. It is possible to configure the Kyma environment so that it allows you to connect to a multitude of SAP systems. Let's walk through some of the drivers of Kyma runtime. The first one is application connector. Application connector enables the connection between external systems and Kyma in a secured way. It handles external events and APIs in the service catalog and simplifies the API usage. It ensures secure access to external systems, and it adopts an event-based mechanism to provide asynchronous communication as well, and also provides monitoring and tracing capability to facilitate operations. Another driver of this environment is the serverless architecture. This architecture manages deployments following a function approach, as discussed earlier, and it ensures scaling independent of the core applications, and it potentially reverts changes without causing production system downtime. And it supports asynchronous programming model as well. It supports loose coupling and ensures application flexibility, scalability, and availability. The third driver of Kyma Runtime is service catalog. It ensures connectivity to services from external sources. It unifies the consumption of internal and external services via the Open Service Broker standard, and provides the standardized API consumption and access, and eases the development effort by providing a catalog of API and event documentation. One of the Kyma use case which I would like to highlight here is about automation of account address verification for sales and service processes. This can be achieved by creating an extension for address validation, cleansing, and geocoding services. The extension is based on the SAP BTP Kyma Runtime open source project. It enables loosely coupled open solutions for complex IT infrastructures. It helps partners and customers to create a flexible foundation for microservices and lightweight serverless functions that connects to SAP CX solutions as well as other SAP and third-party applications. Business benefits include detailed and correct customer account address information to plan efficient routes for sales teams or to schedule an optimal day for a field technician. And technical benefits include the freedom and flexibility to choose the service provider for address verification, the ability to use the language of your choice for side-by-side extension development, and elastic scalability of the deployed extension application. Now coming to the development approach. So now that we have established key architecture patterns to build modern, scalable, and highly available cloud solutions, let's discuss the development approach you should follow for an SAP BTP-based development, including the essential steps involved. SAP BTP is the primary platform to build extension applications for your core line of business solutions, or on-premise solution, and integrate inter-system processes and develop innovative net new use cases. As far as the core development process is concerned, a bulk of development is done for extension use cases. So we will focus on the development approach in the context of extension use cases, although a similar approach is available for new applications as well. On a broad scale, for extension application development in SAP BTP, you need to follow 5 steps as shown here: connect, build, access, deploy, and operate. In connect step, you connect the SAP BTP system with other backend line of business solutions such as SAP S/4HANA or SAP SuccessFactors. SAP Extension Suite provides an easy way to connect these backend systems to SAP BTP sub-accounts. In addition, you need to know the APIs, events, and integration contents for integrating these backend systems to SAP BTP. APIs and events are the real backbone of their extension framework that enables line of business processes to be extended on SAP BTP as a side-by-side extension. For this, you use SAP API Business Hub as the centralized portal to access all the content for whitelisted APIs, events, and so on. The next step is build. Here you build the endpoints. So once you have set up the connectivity, you are now ready to build apps in SAP BTP. SAP BTP provides a host of services to support developers in building applications. A range of low code or no code and pro code tools are provided. The low code, no code tools are extremely helpful for Power Business users to develop business functionality in SAP BTP without going deep into technical details. For Pro Code development tools, SAP Business Application Studio has been provided, which is a cloud development environment. Also, developers can use Visual Studio to have a local development environment. For ABAP development, SAP recommends using Apache Eclipse with ABAP development extension tools. In addition, other open source programming models such as Spring Boot can be realized, and cloud native development can be done in SAP BTP Kyma Runtime following microservices principle. The next step is add channels. Once the core applications are built, you need to provide channels through which these apps can be accessed. The key channels for the access are web and mobile. SAP BTP provides programming models like SAP CAPM, ABAP RAPM, MDKs, and SDKs to create web or mobile channels. And the next step is to deploy your application. SAP BTP gives plenty of choices and deployment platform for your apps. For front end, it provides two flavors, SAP BTP Launchpad and SAP Workzone. And the runtimes available in BTP for deployments are Cloud Foundry, which is an enterprise-ready business applications, and which can be used to build enterprise-ready business applications and services, and to build cloud-native web apps. Another one is serverless. So this we can use to deploy event-driven serverless functions, lightweight extension, and this can also be used to start jumpstart journey from development to production. And another one is Kyma, which helps in cloud native development of applications and services, and which is highly scalable microservice based apps. And this environment is containerized one. And finally, we have ABAP Runtime, which allows for user-centric process extension and allows for robust transactional building of robust transactional cloud apps, and in migrating and adapting add-ons to the cloud. And the final step in the development approach is operate in your organization. SAP BTP provides various tools to operate applications on the platforms. First, you can use the SAP BTP cockpit to do almost all the administrative tasks such as user management, role management, deploying and running applications, maintaining connectivity and security, and so on. The SAP BTP cockpit provides an effective UX to end user to operate your cloud applications seamlessly. In addition, the SAP BTP Cloud Foundry Runtime and SAP BTP Kyma Runtime provide command line interface support, which is very powerful and comes in handy to automate administrative jobs. For example, when you operate production scale DevOps, you may have to set a pipeline for automated testing and deployments. And for such capabilities, you can use the command line interface commands to write the deployment scripts. And with this, we come to an end of this webinar, and the platform is now open for question and answers.
Yes, thank you so much for that great presentation, Juhi. And yes, for those of you, I did get a few questions while the session was going on, but for those of you that have questions right now, feel free to enter them either in the Q&A box or in the chat box, and we will get to them. In the meantime, Juhi, I'm going to get to the first question that we did get, which was, could you explain the key items to watch out for during a brownfield implementation of BTP?
Sure. So that's a very good question. So when we are doing a brownfield implementation of BTP, we already have an ERP running in our IT landscape. And I will take an example of a report over here. So for example, there is a report to see an aging of stock and the open purchase order related to those open stock, those aging stocks. Then usually in SAP, we will see an output in the form of an ALV, which can be sorted by the aging of the stock. But in when we are doing the BTP implementation, we can leverage the other services provided by BTP. So instead of preparing an ALV report, we can modularize the business logic in the form of functions which can be exposed using OData, and then we can consume this in the form of APIs and display using SAP Analytics Cloud. So this Analytics Cloud has enhanced capabilities which can give you more insight. So but if you don't want a complex tool like SAP Analytics Cloud, you can also go for, custom front-end creation using SAP Fiori or SAP UI5 to create micro charts and bar charts, etc. So this way, you see there is a difference when there is a brownfield implementation. So you have to think a little bit different of how you can leverage the SAP BTP services and get more innovative solutions out of it. And the same goes for every other custom objects which can be there in your existing ERP environment. So like enhancements and forms and all. I hope this answers the question.
Awesome. Thank you so much, Juhi. I think it feels like I'm just about to ask you my second question. I think both of these would be a good topic for the next BTP roundtable in August. The next question is, can we integrate ChatGPT with SAP BTP? Or ChatGPT with SAP, ChatGPT with SAP BTP. I think you've got the idea there.
So thanks, Amy. So yes, the answer is yes. In short, we can integrate ChatGPT with SAP BTP, and the simplest way to do it we can use the APIs provided by the OpenAI platform for the different kinds of services which they are providing, and it is very easy to integrate using these APIs. And if you don't want to use the APIs, then BTP gives many other options like open connectors and cloud integration, which we can further explore according to our use case or requirement, or even we can use Event Mesh also for that matter.
Awesome. I see one more question. How can smart forms and SAP scripts be used in BTP?
That's a really nice questions. So I think we have other services provided in BTP. We need to explore them because, as I said, it is preferred in case of BTP to explore, expose all of your business logic in the form of OData using APIs and creating APIs out of that, and further using them to, use the different services in SAP BTP. So as of now, I do not have the service name with me, but I am sure there are plenty of services. Like I know that there is a document service, but it's not used for probably printing the documents, and it's only used for classifying documents. But I'm sure there must be other services available as well. So yeah.
Okay, and then we've got another question. What is the average monthly cost for BTP using the basic services to achieve an integration between SAP and other systems?
So as far as I know, there are different billing models, and then there is a comprehensive enterprise billing model where you have to pay 10K per year on a contract of 1 to 3 years. And in this model, you will get all these services provided by BTP, but this can be an expensive model if you just want to deploy an SAP Fiori app on a cloud environment. So you can also go for a pay-per-use basis, which will only charge you for the services that you use. And there is one more model similar to this enterprise model, whose details I do not remember right now, but you can go to SAP Discovery Center and you can find a calculator which you can use to, you can add the services which you want to use and later find out how much the billing is.
Awesome. Thank you so much. I think I'm just double checking. I think we're done with questions. Juhi, did you want to proceed to the contact us form?
Sure.
Yeah. All right. I think we're ready to wrap up, actually. If anybody does have questions after the session, you can reach out to Juhi or myself. And in the case of myself, I will get you in touch with somebody who can answer the question better than I can. Definitely better than Yeah, definitely better than I can. The recording of today's webinar will be available on Mindset's YouTube channel later this week. For those of you that are interested, we do have our next event coming up on June 22nd. It is our quarterly Fiori Roundtable. Complete details and registration is open right now on the Mindset events page. We also have a BTP Roundtable that we host quarterly. The next BTP Roundtable will be in August. So hopefully you can join us for any of those. And again, thank you so much for spending your time with us today. And I hope to see you again at another Mindset event.